Hello everybody, today I will talk about my project, License Plate Recognition. The license plate recognition system plays a real important role in modern society, such as parking management, and toll station management, and so on. And to implement the license plate recognition, we should do three steps. First is license plate location. Second is character segmentation. And the third is character recognition. First, let's see the license plate location. Positioning the license plate from image which we input in the system by unique feature information such as plate size, length, and words. Among many features, age features and color features are the two most unique. So we detecting the license plate of the cars using the age features has higher accuracy. Pre-processing of image because of the natural environment, shooting equipment and shooting orientation and the other objective factors in the process of obtaining the license plate image. The image may be burned, and the image needs to be pre-processed by certain protectors to ensure the image. Now, let's do the grayscale processing. Usually, all the car images are color images. The input of color image will cause a large amount of computational burden on the recognition system. But the grayscale processing operation can not only reduce the amount of information in the storage space, but also reduce the subsequent images. And next, let's see the medium filtering and gradation transformation. The license plate image will be mixed with a lot of noise during the storage and the transmission process. In order to avoid the troubles caused by the backward, it needs to be denoised. Now let's see the edge detection. Because the license plate has a series of geometric features such as special aspect ratio, and the information on the edge of the area is very rich, and the gray values of the characters and the background are also very different. So through the computation of the above algorithms, this paper chose to use the Sabo operator, which can efficiently process noise in the process of detecting images, and has large response to the edges, which can further narrow the research scope and remove information unrelated to license plate images, reduce the amount of data processed. Here is the image that we have processed. And you can find that the noise of the license plate is become more and more smaller, and the license plate can obverse in the age detection. Now let's do the morphological range filtering based on binomial images. Binomialization means that the image is responsible by only black and white. Since it can reduce the amount of calculation, it occupies a very important position in language image process. And expansion and orations are the two basic operations. First, the image is closed. The purpose is to remove the lateral edges and objects smaller than the structure images. If there is a small communication between the objects and the textual images are large enough, it is enough to subsprint the two objects, eliminating narrow grids and zooming the near bound of the object. Secondly, the over operation is performed. The narrow discontinuity is broken. The small proportions are eliminated and the target counter is zoomed. Now here is the expand field result. You can find that the location of the license plate is become a large place, and then we can use this use some features to judge the location. Because the license plate has a series of features such as a special aspect ratio, the regional license plates in Florida are all rectangular, and the ratio of length to width is also about 3:1. According to this feature, the entire image is completely scaled. The binomial image is screened line by line, become top to bottom. The number of black and white jumps of each line is recorded in the horizontal direction and compared with the surround set in advance. And the total number of jumps per line is less than the surrounder. It is determined as a non-license plate in the different area. The area which don't have license plate is removed. The remaining part is the license plate area. And from this series process, we can find the license plate location, and here is the result. And this is my car, and I take these photos by myself. And you can see I can directly find the license plate in the picture. And then let's talk about license plate segmentation. After finding the license plate, we need to segment the character. Character segmentation is a step that is indispensable for most drive plate recognition systems. The quality about segmentation directly affects the effect of next steps. In order to effectively segment the characters, a suitable gradation conversion mask must be applied to the input samples, and the license plate border needs to be removed to complete the accurate representation of the plate. Finally, the drive plate is proceeded in combination with connecting component arrays which the vertical projection uses to extract all the characters. The character segment used in this paper is based on vertical projection, which mainly uses the continuous characters of the plate character. When the image is subject to a series of pre-processions, we project it vertical to achieve the purpose of theoretical segment. Binomial plate to open the description of white praxis in the horizontal direction. We know that there is a very important difference between the characters on the license plate and the background of the license plate. So we can use this feature to identify the characters, and there is a certain interval between the character and the other character. So after the projection, the place where the white pale's projection is expressed is different as the source, and the rich base is defined as the peak. The character segment used in paper is with. Okay. The license plate contains 6 characters, and there are images in the median of the license plate of Florida. And their vector projection difference will show the phenomena of peaks and various alternation. Observed, it is very likely that the source is the boundary between the characters, and the peak may be the plate character area. Select a approximation surrounding, cut the characters above surrounding as the characters, and finally get the target image. Since the length of the image is significantly different from the length of the character, we can emit the image in the license plate by calculating the length of the segment character. Now let's see the results. Here is the license plate that has been nominated, and here is the characters that after segment the license plate. And at last, we should do the character recognition. Character recognition is used one of the classification to recognizing the image which has been split in the license plate. Here we use a convolutional neural network. The traditional C neural network consists of an input layer, an convolution layer, a polling layer, a hidden layer, and a classification layer. The input layer generally accepts the color or graphical image as input, and the convolutional layers and the polled layer generally appears in pairs. The former is responsible for the extraction of sample features. The latter is responsible for subtracting the extract features. The hidden layer is responsible for spatial transformation of the characters extracted by the convolution layer and a polling layer, and a classification layer is responsible for dividing the changed features. Now let's see the convolution implementation. The primary rule of the convolution in convolutional neural network is to convert on the input image using a fixed size convolution kernel and wedge the convolution kernel and sum the values corresponding to the input image. And polling implementation. Since the polling operations don't overlap, the number of features that the network backend classifier needs to process after polling is reduced. Another advantage of polling is that since the polling measures the maximum value as the output feature value, the C neural network can quickly extract the input image even if input image has a series of translation, destruction, and blur. Now here is the mainly process of the convolution neural networks. Now let's training our classifier. The character recognition in my project, which based on the results of character segmentation. The output of character segment is composed of 6 number or letters. This paper selects more than 4,400 learning samples for training, including members from 0 to 9 and letters from A to Z except O. Because O and 0 Z may have the same features in my opinion, so I can't successfully recognize them. At the same time, 100 test sets are also provided from cross-validation, aimed at verifying the accuracy of the classification system. My paper is on the basis of 332 protests for 40 image input, which is narrow in the two different scale images. And here is the convolution neural networks settings of my program. And now let's see the training results. I get the iterations to 100, and you can find that when the iterations reach the 20, the accuracy has reached at 95%. It's very high in training. And here is the cost time. Now we have trained the classifier. The next step is to identify the characters we have separated from the license plate. Since I have already stored the display characters in the font, the classifier also reads the image directly from the font. So I directly on the command line run the image segmentation programs and C neural networks production program. And here is the project result. You can see the last license plate, my C neural networks processor is IE45BF, and which is suitable to the image in my picture. So I think the project is very successful. And this paper identifies the three standard fields in Florida through the 3 steps license plate location, which first located the plate character segmentation, which slipped the plate to 6 characters, and character recognition. The C neural network structure of my project has a better recognition accuracy rate than the traditional neural network, and has better stability. The recognition optimize the parameters in the recognition system by learning a large quantity of license plate character pictures. In practical applications, it is necessary to further develop the number of samples and the number of network training data, and change the neural network structure to observe and improve resolution is also very important. Of course, my project has some disadvantages. Because of the license plate recognition in daily background makes the complex very high. The lighting conditions varies greatly. The license plate size in Florida is very different. The position of the license plate of the car is not fixed either. So the license plate position ways used in my paper may only locate the simple license plate. The problem has not been studied for the problem of multiple license plate. Meanwhile, because the date collection of the license plate characters of Florida 0 and O is difficult to identify, so in my object, I just recognition the number 0 and ignore the O. Finally, as for the traditional C natural network, the license plate recognition characters itself don't have a large degree of change, while the noise ratio is low, and the number of labeled characters is also not very high, so the structure needs to be further improved. And now, thank you for your watching. Oh, and at last, I will demo my programs. Now let's first see the films. My program has two parts. One is CNN and another is image. In the image program, I do the license plate location and license plate segmentation. Now let's run the program. You can find the production image now is empty. Now I run the image program. And you can find this is the license plate after we location the plate and bare minute yet. And now you can see in the production images films we have 6 characters, and these 6 characters are the license plate in the picture and has been segmented. And now let's do the projection. Because I have already trained the CNN, so here I just do the project of the license plate. Oh, it's a little slow. Now you can see the results. IE45BF. Yes, I think it's project very successful. And at last, let's do the train of the CNN. Because I have already trained the CNN program, so here I should delete the trained one. And I will change the integrations because it costs too many times when the integration is 100. So I will reduce it to maybe 30 or 20 to just let you to see the train process. Now I train. Yeah, maybe 30. And then let's train the CNN program. Okay. And first, it will question the training data. And my training data is in here. Training set. From 0 to 9, and from A to Z, except O. Here is the training data, and this is the validation data, which can do the cross validation and get the training and acquitals. Now you can see totally read 4,400 training images, and the first now you can see the first training iterations. The accuracy is only 9%. It's very low. And when the number of iterations increased, the accuracy of the training is increased very quickly. And and when I do 30 iterations, the accuracy of the training can reach 97. Because it costs a lot of time to training, so I stopped the video in a couple of times and now start again to let you see the training progress. And now my project presentation is over. Thank you.